first chapter, that is units and measurement. ओके आज हम अपना फर्स्ट चैप्टर स्टार्ट कर रहे हैं 11th फिजिक्स का, दैट इज यूनिट्स एंड मेजरमेंट. नाउ दिस चैप्टर इज बेसिकली related with the quantities, physical quantities, and then derived, their units, their way of measuring. Now the first thing comes is what is unit. Now unit is actually the measurement of any physical quantity. It is the measurement of any physical quantity. Okay, when you measure any quantity, any measurement of any physical quantity by what? A reference, and that standard reference is known as what? Unit. So this is actually how we define a unit. And when we talk about the unit, so units are of basically two types. One is the फंडामेंटल यूनिट्स, एक होती है फंडामेंटल यूनिट्स जिनको हम व्हाट वी से बेस यूनिट्स, एंड द अदर इज derived units. Derived units. So fundamental units are used for fundamental quantities. They are used for fundamental physical quantities. And derived units are used for derived quantities. Actually, derived quantities comes from the fundamental only. So they are used for derived quantities. They are used for what? The fundamental physical quantities. Now, how you define a physical quantity? Question is there. If physical quantity, how we are going to define? Now, physical quantity. Now we have heard of physical quantity like mass, length, time. So physical quantity has what? A particular number, units. How we define, say, a quantity which can be measured, and by which various physical happenings can be explained, okay, and expressed. We can say expressed also in form of laws is called what? A physical quantity. Now we know that physical quantity, like we say that, example, we have mass, length, time, relative density. This is also a physical quantity. We say velocity, we say displacement, okay, distance. Now these are the physical quantities. Now if you see the types are what? Now if I talk about the types of physical quantity, now types of physical quantity. So what we see here is that some quantity are actually in the form of ratio. Example is relative density. You have gone through in class 9th, relative density, density of body upon density of water. Even you have gone through a quantity in class 10th, refractive index. Remember, mu equal to C by V. It is also a ratio. Then second is scalar quantities. स्केलर मीन्स ओनली मैग्नीट्यूड, सिर्फ मैग्नीट्यूड होता है, नो डायरेक्शन. So scalar quantities are those only magnitude. Example, if we say mass has only magnitude. Okay, charge. Okay, work, energy, all are scalar because they don't have a direction. And the third one is vector. And vector, we are going to go through this chapter in detail later on, but vector has magnitude and direction, both. It has both magnitude and direction. And you know what are the example? Example are displacement. Example are velocity, force. So these are the example for what? The scalar quantity. So what we see is some are in the form of ratio, some are having no direction, some are having both direction and magnitude. So these are. Now when we talk about the physical quantity, so physical quantity, say it is denoted by Q. Q is a quantity, Nu. Now if you ask you what is Q, it is a quantity. What is N? Number. And what is U? Unit. We talk about the unit. And say mass equal to 1 kg. What is mass? It's a quantity. What is 1? Number. What is kg? Unit. But then we know that mass can also be written as 1000 gram. It is also a quantity. It is also a number. It is also a unit. So when we say Q is equal to Nu, can we write what? N1 U1 equal to N2 U2? Because 1 kg is equal to what? 1000 gram. So what we see here, N1 U1 can be written as what? N2 U2. So this is how we say that N is inversely proportional to unit. More is the unit, less will be the number. Kg is bigger than gram, but the number 1 is less than 1000. So N is inversely proportional to what? Unit. So this is what we talk about is the magnitude of physical quantity. We say magnitude of what? Physical quantity. So got it? How we say that? Yes, 1 kg can be written as 1000 gram. Now, you know that there are some fundamental and derived units. So when we talk about fundamental, okay, then we know that fundamental, what are the base quantities? First we'll talk about the base quantity. Now the fundamental quantities are the base quantities. Base quantity. And what are those? We know the length. We know mass. We know time. Okay. You know electric current. Then temperature. Then amount of substance. And then there is luminous what? Intensity. So these are the base quantities. And then what we say that their name, we know that their symbol is actually denoted when we talk about the symbol. We know that it is meter, mass kg, time second, okay, current is in ampere, that's their unit, temperature is in Kelvin, and then amount of substance is in mole, and this is in candela. So fundamental quantities are these are the fundamental units for them, and these are 7 base quantities. So they have fundamental units. These are the fundamental units. What we say here, these symbol are basically their units. Mass, length is measured in meter, mass in kg, time in second, current in ampere, temperature in Kelvin, amount of substance in mole, and luminous intensity in what? Candela. CD. So 7 fundamental base quantity are there. Now the rest of them are derived quantities. Some are practical quantities. Now we know that if you want to express derived units, say I am talking about these were the fundamental derived units. Now if I ask you what is velocity, you will say it is displacement upon time. Now this is a derived unit you are going to get for it. It is meter per second. What is acceleration? Then I think all of you know it is velocity upon time. Then it is meter per second square. So these are the what? Same is the force. Force is mass into acceleration. Mass is in kg. Acceleration is meter per second square. These are the derived units. And some are practical units also. You are going to use in practical labs when in higher studies also practical units. Like 1 Fermi nuclear distances are measured 10 to the power minus 15 meter, or 1 angstrom is 10 to the power minus what 10 meter. 1 X-ray unit, these are the units, they will be used in the lab also, in the practical units, 10 to the power minus 13 meter. So these are the practical units which are going to be used. So fundamental, derived, and then practical units. Okay, got it. So there are one is 1 astronomical unit, 1 AU. This you are going to measure in the gravitation also in the measurement of length, 1.49 into 10 to the power 11 meter. So this is 1 astronomical distance, 1 astronomical unit. So these are the practical units. Now we'll talk about the system of units. Okay, so system of units. Now when we talk about the system of units, I think all of you know there were a number of systems made, and some of the system are what? The first one is CGS system. The second one is MKS system. And then some of you may be knowing FPS system. And the last one, which is nowadays, which we use in our standard units, that is SI system. So CGS system, we know that it was length for centimeter, then gram, then second. Okay, then if for this length was in the what? Meter, then mass was in kg, and time was in second. Then in FPS also we know that it was foot, pound, and then what? Second, FPS. And then comes what? The SI. We know that SI has what? We know that it has length is in meter, mass is in kg, time is in what? Second, current is in what? Ampere, and then temperature is in what? Kelvin. Then amount of substance, we have just gone through this, amount of substance is in mole. Okay, and then luminous intensity is in what? Candela. So this is what? SI system, CGS system, MKS system, FPS system. These are the system of units. And you know that we have two different units also. Fundamental we know, derived we know, practical you know. We either have two units, and one is, those are known as what? Supplementary units. So supplementary units. So supplementary unit. And those supplementary units are two. One is radian and one is what? Steradian. So one is used for plane angle, and like you measure an angle, and this is used for what? Solid angle. So radian and steradian, like we have this as a plane, there's an arc, and we have an angle d theta here. This is the R, This is the arc length, ds. I think you may be knowing how d theta is measured, is ds by r, arc, okay. You know that length L is equal to r into theta. You have gone through this is in mathematics also, arc. And this is for what? The plane angle, okay. And then there is another one, what? A solid angle. Now solid angle, if you have seen an ice cream cone like this, now this ice cream cone has an angle here. You know that it's a solid angle, and this is the radius. Okay, same is here also. If I ask you, this will be in this shape and this will be in this shape. So this, there is an angle here inside it. This is the angle, and that angle is d psi, it is r. So it is not d theta, and this is the area of this one. This is the area. You see here, I have compared with the ice cream cone. So say this area is dA. So d psi is denoted by dA by r square. So this is solid angle. Though you are going to deal mainly with the plane angle, but this is a solid angle. So one is radian, one is steradian. These are the supplementary units, and one is for the solid angle. You have seen this is the ice cream cone. I will given you example. This is a plane angle. So how we note these supplementary units? Now we'll talk about something related with the most important, and that is dimensions. Now generally what we say is that dimensions are what? The length, mass, length, time. But the dimension of physical quantity, how you denote it? Do you know? Dimensions, what are those? Dimensions of a physical quantity, any physical quantity, dimension of any physical quantity are actually power raised to what? Fundamental units. Fundamental units means that is mass, length, and what? Time. That is MLT. Any physical quantity which is denoted by these fundamental MLT. Now you know that M is denoted by what? Mass. So this is the dimensional formula for this. And you know it can be written in this form. M L T. Here L is 0, T is 0. Because mass, it is for mass. The power, the dimensions. If I say the dimensions are A, B, C. So what is the dimension of A? Is 1, but B is 0. C is what? 0 for mass. Then if I talk about the length, how we denote it? You know that we denote length as like this, or we can denote it in the form of MLT. Now which will be 0? M0, T0. So again here, what if I ask you what is A? A is 0. B is what? 1, and C is 0 this time. And if I talk about the time, time is T, and we know that it can be written in this form also. M, L, T. Now these two will be 0, but T will have a power, but time. What is A here? 0. What is B here? 0. What is C here? 1. So dimensions are the powers used for the physical quantity. Mainly the dimensions are in the form of mass, length, time, but we can denote it for what? Say temperature. So for temperature, we know that temperature also, sometimes we know that temperature will be denoted by K. And then like current, so for current we have what? Ampere. But basically they are written in the form of what? Mass, length, and time. Now what we can do, we can find the dimensions of the physical quantity. So I am giving you an example. Say the question comes, write the dimensions and dimensional formula for what? Say velocity. Now very simple. What is velocity? It is displacement upon time. Now if I ask you what is the What is the dimension of displacement? Displacement is actually a length. What is time t? So what it will be? Lt minus 1. Can I write in this form? Yes, m0 Lt minus 1. So the dimension here A is 0, B is what? 1 and C is minus 1. So this is dimensional formula and these are the dimensions. So we can find out dimensions for any physical quantity which we know generally all the physical quantities which we are going to deal in class 11th. So this is how we start with the dimension. So dimension are mass, length, time, and this is the dimension. Like I can give you an example of say momentum. Now I think linear momentum, you know, linear momentum. So for linear momentum, what you write is mass into velocity. P is mass into velocity. Can you tell me what should be the dimension? What will be the dimension of mass? And what is the velocity dimension here? Lt minus 1. Can I write the formula here? Yes, mlt minus 1. So this is dimensional formula for what? Linear momentum. So this is dimensional formula. Okay, so in this way, we can know about the dimensions, how we find out the dimensional formula. Okay, thank you and regularly watch my videos.